On November 5th, 2025, the Virtual Telescope Project released 2 new images that reignited one of the strangest mysteries in modern astronomy, the interstellar object known as 3, I divided by Atlas. What these images revealed was not clarity, but confusion. Atlas appeared as a compact, almost motionless point of light, showing no trace of the comet-like activity scientists had expected. Even more astonishing, its appearance was nearly identical to what the Hubble Space Telescope captured 4 months earlier in July 2025. For something traveling through the inner solar system, exposed to the full intensity of the sun, this was completely unexpected. By now, Atlas should have lost a significant portion of its mass, roughly 13% of its total, or over 5.5 billion tons of material. According to Harvard astrophysicist Avi Loeb, such loss would normally produce a vast cloud of gas and dust surrounding the nucleus, a radiant halo easily visible to even modest telescopes. But that halo is nowhere to be found. Atlas shines like a single, clean bead of light suspended in darkness. To understand how strange this is, the video compares Atlas with a familiar visitor comet Lemon. Under the same solar radiation, Lemon glows brilliantly with a luminous tail stretching millions of kilometers away from the sunday. It's the perfect demonstration of what happens when sunlight vaporizes surface ice and drives outgassing jets. But Atlas? It remains perfectly clean, as if immune to heat itself. No tail, no halo, no sign of material being shed. For an object that appears to be accelerating without losing mass, the mystery only deepens. This is not behaving like any natural object we've ever seen, Loeb explains in a recent interview. If you apply physics as we know it, the numbers simply don't add up. And that's where the story begins, with a question that could change everything we think we know about interstellar objects. On October 29th, as Atlas made its closest approach to the sun, something extraordinary happened. NASA's Jet Propulsion Laboratory detected that its trajectory had shifted not slightly, but dramatically by cosmic standards. The deviation measured 4 arcseconds from the predicted orbit. To most people, 4 arcseconds might sound negligible, but at a distance of 203 million kilometers, that translates to an error of more than 80 kilometers. Something had pushed Atlas off course, not once, but continuously over several weeks. JPL's report described an acceleration of 0.2 millimeters per second squared. It may seem tiny, but across interplanetary distances, that is immense. More intriguingly, the data showed not one acceleration vector, but 2. One pushing the object outward from the sun, the other sideways across its path, as if Atlas were being steered. NASA was quick to clarify that there was no threat to Earth. Atlas's orbit, while unusual, posed no collision risk. Its next significant encounter might come in March 2026, when it passes near Jupiter. But that reassurance did little to calm the growing scientific unease. Because if Atlas is being pushed by what? Imagine throwing a baseball and watching it follow a perfect arc dictated by gravity. Now imagine that same baseball suddenly veering off course mid-flight as if invisible thrusters had fired. That's precisely what astronomers are seeing with Atlas. It's not obeying the laws of celestial mechanics. The standard explanation for comet acceleration is simple: outgassing. As sunlight heats the surface, frozen volatiles like water, carbon dioxide, or ammonia vaporize and shoot off as gas jets, giving the comet a tiny push. Over time, these jets can noticeably alter its orbit. But in Atlas's case, the math doesn't work. To produce the measured acceleration, the object would have to vent an impossible amount of material, more than 5 billion tons of gas in a single month. That kind of mass loss would produce a vast, glowing envelope easily visible from Earth. Yet the images show nothing, so what else could be driving it? An unknown physical mechanism? A form of propulsion we've never observed? Or something more deliberate, perhaps even technological? Avi Loeb decided to take the problem back to basics. Using first principle physics, he calculated the amount of gas required to achieve Atlas's measured acceleration. The result was absurd. Atlas would need to shed 1/6 of its total mass over the course of a month. No known comet could survive that. And yet, Atlas remains intact, bright, and oddly unchanged. Its estimated mass, roughly 33 billion tons, makes it colossal, larger than any interstellar object we've ever detected. It's between 1,000 and 1,000,000 times heavier than either of its predecessors, 1I, or Oumuamua, and 2I divided by Borisov. Its core spans nearly 6 kilometers across roughly the size of Mount Everest. Given that mass, the forces required to alter its motion are staggering. Nature should leave a fingerprint, but it hasn't. Between late November 2025 and January 2026, a fleet of telescopes from Hubble to the James Webb Space Telescope will monitor Atlas continuously. On December 19th, when it makes its closest approach to Earth, just 167 million miles away, scientists hope to catch the definitive evidence, the elusive gas cloud that should exist if outgassing is real. If they see it, the mystery ends. If they don't, something extraordinary must be happening. Because without that cloud, the natural explanation collapses. And what's left might be something far beyond current science, an indication of a controlled or even artificial acceleration. This wouldn't be the first time such an anomaly has shaken astronomy. In 2017, the first interstellar visitor, Oumuamua, displayed a similar non-gravitational acceleration. Yet, Spitzer's deep infrared scans revealed no signs of gas or dust. Researchers, unable to categorize it, reluctantly labeled it a dark comet, a contradiction in terms, since comets, by definition, shine through outgassing. Atlas, however, takes that paradox to a whole new level. As it neared the sun, its brightness increased at an unprecedented rate following a power law of -7. Typical comets brighten by -2 or -3. Atlas doubled that intensity, glowing far faster than expected. And then there's the color. At its perihelion, Atlas appeared blue, bluer than the sun itself. Natural dust scatters light toward the red end of the spectrum. Blue implies either ionized gas or an extremely hot, reflective surface. But how could an object so cold, 20 times colder than the sun's surface, emit light that blue? Cold things glow red, not blue. Some scientists propose that Atlas might be emitting ionized carbon dioxide or molecular oxygen, but the spectral data doesn't fit neatly. Others suggested metallic reflection, perhaps from a dense, structured surface. Whatever the cause, the result is the same. Atlas refuses to behave naturally. This, the narrator explains, isn't a video about claiming extraterrestrial origin. It's about method. Science begins with data, not with comfort. When data doesn't match the theory, you don't discard the data, you refine the theory. Yet, many researchers have done the opposite, dismissing Atlas's behavior because it doesn't fit established models. Loeb calls this bad science. As of November 2025, the scientific community stands divided. Some argue that Atlas must be a comet. No matter how strange, Others believe it represents something entirely new, a natural phenomenon we've yet to understand. And a smaller, more radical group entertains a bolder hypothesis that Atlas might be technological, a probe from another civilization. For now, no one can prove any side right or wrong. But one thing is certain, something is pushing Atlas across the void, defying gravity, logic, and perhaps even our understanding of what's possible. And the closer it gets, the more urgent the question becomes. What exactly is Atlas? Atlas is no longer just an astronomical curiosity. It has become the most scrutinized object in the sky. Every night, telescopes across the world point toward the same moving point of light, tracking its trajectory as it continues to defy the laws of celestial mechanics. Scientists, amateurs, and theorists alike are chasing answers, but what they find only multiplies the questions. The deeper researchers dig, the stranger the data becomes. Atlas doesn't simply break one rule of physics, it breaks many. Its motion, brightness, color, composition, and even its timing all seem to contradict the natural order. Together, they form a pattern, a list of 9 anomalies that may redefine what we understand about interstellar visitors. The first anomaly is its orbit, the impossible path. Atlas travels on an orbital plane tilted only 5 degrees from the ecliptic, the same flat disk in which all planets orbit the Sunday. For an interstellar traveler, this is almost impossible. An object entering from another star system could approach from any direction, at any inclination. Yet Atlas moves nearly parallel to the solar system's own plane, as if it had been guided intentionally. Statistically, the odds of such an alignment occurring by chance are near zero. Astronomers compare it to shooting an arrow across galaxies and hitting a coin resting flat on a table. Some suspect that Atlas's near-perfect orientation could indicate purposeful navigation, or at least influence from an engineered trajectory. The second anomaly, the physics-defying jet, was observed during July and August 2025. While most comets eject gas and dust away from the sun, forming a glowing tail that stretches behind them, Atlas did the opposite. It released a narrow jet directly toward the sun, a reversal of all known cometary behavior. It's as if someone were running into the wind and their hair streamed forward. The idea defies solar radiation pressure and basic plasma physics. The only way such a jet could exist is if it were magnetically or electrically controlled, perhaps a form of directed exhaust rather than random sublimation. Then comes a third anomaly, the paradox of size and speed. Atlas is not a small object. It's a mountain of ice, rock, and metal roughly 6 kilometers wide and weighing over 30 billion tons. By all normal rules, massive bodies move slower under the gravitational grip of their parent stars. Yet Atlas moves faster than smaller interstellar objects like Oumuamua and Borisov. Something enormous is moving with a lightness that shouldn't be possible. The implication is disturbing. Either its density is far lower than estimated a hollow shell, perhaps, or something inside it is generating thrust. An even more astonishing feature is its backspin. Observations indicate that Atlas's rotational direction, combined with its jet orientation, would create a propulsion-like torque as if maintaining a controlled spin. Plasma physicists studying the data propose a bold theory that Atlas might be surrounded by a magnetic field interacting with the solar wind. Such a mechanism could generate controlled thrust, similar to ion propulsion technology that humanity has only begun experimenting with. The fourth anomaly is timing, perfect, deliberate timing. Atlas's arrival and orbital path have synchronized almost suspiciously well with planetary positions. It passed near Mars, then Venus, and then Jupiter, all while avoiding close encounters with Earth. Statistically, the chance of this precise choreography is vanishingly small. If Atlas were a random comet, its trajectory would be chaotic. Yet this one follows what looks like a calculated route, slipping through gravitational corridors as if following a pre-designed map. And that leads to the fifth anomaly, the factory pattern. Astronomers studying the route noticed something unusual. Atlas's encounters with major planets seem optimized to collect gravitational or electromagnetic data. Each flyby provides a unique scientific window, as though Atlas were conducting a survey of the solar system. Its path avoids danger, yet maximizes observation opportunities. This peculiar pattern has inspired a daring theory that Atlas might be an automated probe scanning planetary fields while staying safely distant from the only world that could recognize it. Spectroscopy then reveals something even stranger, the sixth anomaly: composition. Atlas's metallic ratio doesn't match that of natural bodies. It contains more nickel than iron, a combination common not in nature, but in engineered alloys the same type used in high-temperature machinery such as jet turbines or spacecraft. On Earth, this ratio exists in alloys like Inconel or Invar, designed for endurance in extreme conditions. It is as if the material of Atlas was once forged, processed, or refined rather than condensed randomly from interstellar dust. Some researchers cautiously suggest that Atlas could be a fragment of a destroyed technological structure, the remnants of something ancient that once traveled through the stars. Its outer layer, observed through spectral reflectance, shows unusually smooth scattering, more consistent with metallic composites than with dust or stone. Others speculate that this layer might even act as a heat shield or protective shell, engineered to survive eons of cosmic radiation. The seventh anomaly is its dryness, absurdly dry. Typical comets are mostly frozen water. About 80–90% of their mass is ice. Atlas, however, contains less than 4% water, making it drier than any known desert on Earth. Even at its closest pass to the Sun, infrared sensors detected no water vapor, no jets, no evaporation. Some scientists theorize that the surface may be coated in refractory materials, ceramics, carbon composites, or even an artificial glaze, preventing sublimation. If this hypothesis holds, Atlas might not just be dry, it might be sealed. Polarization studies uncover the eighth anomaly, a signature never seen before. Light reflected from Atlas carries an electromagnetic polarization pattern that doesn't match any known comet, asteroid, or interstellar rock. It behaves like light bouncing off a smooth metallic or crystalline surface, the kind produced by precision manufacturing. This observation connects eerily with another historical puzzle: the WOW signal, the mysterious radio transmission detected in 1977 from the constellation Sagittarius. Both Atlas and the WOW signal originated from nearly identical coordinates in space. Could it be coincidence? Possibly. But the alignment is too precise to ignore. The polarization curve from Atlas resembles the kind of reflection one would expect from flat or angled surfaces, mirrors, panels, or solar arrays, rather than random mineral textures. A few scientists quietly entertain a shocking possibility that Atlas might possess large, reflective structures, perhaps akin to solar sails or data collecting plates. And then comes the ninth anomaly, the one that defies belief: temperature. Atlas appears hotter than it should be, much hotter. Its bluish hue implies thermal emission beyond 5,800 Kelvin. Rivaling the surface of the Sunday, no natural, non-stellar body can radiate such heat without disintegrating. The spectral color cannot be reconciled with its distance, mass, or expected composition. If this observation is correct, the only explanations left are either a completely new physical phenomenon or the presence of an artificial energy source. This combination of anomalies, orbit, jet, mass, timing, composition, dryness, polarization, and heat paints a picture so strange that even the most skeptical scientists have begun to question whether Atlas could really be natural. Each factor alone might be dismissed as coincidence or mismeasurement. Together, they form a coherent, disturbing pattern, one that points to design, not chaos. If these data hold up, Atlas may not be a comet at all, but something else entirely, a visitor carrying technology or intent, a silent messenger from a civilization long gone or perhaps still watching. And as it moves steadily closer to Earth, the world waits, breath held, for the night of December 19th, the night humanity may finally learn the truth about the object called Atlas. As December approaches, tension builds across the scientific world. Every observatory, from Chile to Hawaii to orbiting platforms in space, is now locked onto a single target, the bright, unblinking light of 3, I divided by Atlas. It glides across the void with quiet precision, as though following a plan written long before humanity learned to look upward. The closer it gets, the more its mysteries multiply. Astronomers prepare for the critical date, December 19th, 2025, when Atlas will pass within 167 million miles of Earth, its closest approach before vanishing into interstellar space forever. Hundreds of telescopes, including the Hubble, Webb, and the European Southern Observatory's VLT, are scheduled to observe it. The goal is simple: to find the missing gas cloud that should explain its acceleration. If they detect the cloud, the comet theory stands. If not, the scientific world will face one of the greatest shocks in modern history. Avi Loeb's team has run the numbers again and again. If Atlas truly accelerated the way data suggests, it must have expelled over 5 billion tons of gas. That would produce a brilliant halo visible from Earth, yet the sky remains clear. The physics is merciless. An acceleration of that magnitude requires an equal and opposite reaction. Without expelled mass, something else must be providing the thrust. Some scientists whisper that Atlas could be hollow, containing a magnetic or plasma-driven propulsion system. Others go further, proposing antimatter reactions, photon sails, or unknown energy conversion mechanisms. The debates grow louder each day, spilling from academic journals into public fascination. Every theory carries the same haunting implication. Atlas may be moving with purpose. Still, official agencies urge caution. NASA, ESA, and JAXA continue to classify Atlas as a comet, albeit a highly unusual one. Their statements remain careful, technical, restrained, but outside the realm of official science, forums, and think tanks buzz with speculation. What if we're being observed? One researcher asks. What if this thing is watching us? For the first time, the question doesn't sound absurd. Some independent astronomers have noticed patterns in Atlas's path, subtle oscillations that could indicate a controlled scan of the solar system. The object seems to sweep across magnetic field lines, tracing invisible boundaries between planetary orbits. It's as though it's measuring something: gravitational harmonics, radio frequencies, or even traces of biological life. Underground scientific forums give this hypothesis a name: the mirror galaxy effect. According to this theory, every time a civilization reaches the nuclear age, a silent observer activates somewhere in the cosmos. It doesn't communicate directly, it doesn't interfere, it simply watches, measuring, recording, assessing whether that civilization poses a threat to the wider universe. Perhaps Atlas is one of those sentinels, triggered by the glow of our atomic dawn. The more scientists examine the data, the more eerie coincidences emerge. Atlas's trajectory intersects the same sector of space from which the famous WOW signal of 1977 originated, a 72-second burst of radio energy that has never been explained. Both come from near the constellation Sagittarius, and both share nearly identical celestial coordinates. Could Atlas be connected to that transmission, or even be its source? Some SETI researchers think it's possible. They propose that Atlas could be a kind of cosmic relay, a self-repairing beacon transmitting at intervals of centuries or millennia, part of an ancient interstellar network. If that's true, the implications are staggering. It would mean that we are not alone, and that contact, silent, passive, observational contact, has already begun. Yet, as December 19th draws closer, Atlas remains silent. No radio emissions, no bursts of energy, no signals of any kind detectable to human instruments. It races through the night sky like a blue spark, accelerating at a rate that mocks every natural model. It does not wobble or fragment. It does not flare unpredictably. It simply moves steady, deliberate, unyielding, and still, it watches. In the final days before closest approach, rumors spread that a synchronization pulse could be detected, a sudden, precise burst of electromagnetic energy, not directed toward Earth, but outward, as if transmitting to somewhere beyond. Would it be confirmation that Earth has been found? Or simply the next step in a plan set in motion millions of years ago by hands not our own? Nobody knows. But humanity waits, caught between awe and fear. If Atlas truly is an interstellar probe, its mission may not involve us at all. It could be cataloging the solar system's planets, updating a database that no living being will ever see, or it could be scanning for radio frequencies, nuclear signatures, or artificial light that mark the emergence of intelligent life. In that case, we may have already been logged another data point in an ancient cosmic ledger. And so, as the night of December 19th arrives, the world holds its breath. Observatories around the globe transmit live images of Atlas, bright, blue, silent, no gas cloud, no debris. Just a perfect sphere of light racing past the sun, accelerating still. For a few brief hours, billions of eyes turn upward, united in a single act of wonder. When morning comes, Atlas is gone, moving outward, back into the deep interstellar dark. But the questions remain. Was it a comet, a fragment of ancient technology, or a silent messenger sent to observe us? No one can say for certain. Yet one idea refuses to fade. Perhaps we are not the only species that gazes into the night and wonders who else might be out there. Perhaps somewhere, across the vastness of space, another intelligence is looking back, studying, waiting, remembering. As the narrator's voice fades, the final words linger like an echo across time. The scariest thing is not what we see in the sky, but what might be seeing us.